Good morning, my beloved viewers. I'm Mr. Okafor PC, your online physics teacher. Today, our topic of discussion is speed, formula for finding speed. Recall, when we did physical quantities, I assured you that you don't need to panic with the formulas, that I'm here to guide you on the formulas. Today, before I will be talking on the formula for finding speed, I will give you the logic behind every formula. There's a logic behind formulas. Recall, physics formulas are not to be crammed. They are to be understood. They are to be carefully understood, not to be crammed. If you must do well in physics formulas, you must know the topic called variation in mathematics, variation or proportion. And it's a very simple idea. Variation talks about variables and constants. The physical quantities can either be a variable or a constant. When it is called a variable, it simply means that it changes. The word variable implies to vary. So any physical quantity that changes is called a variable, while the physical quantity that does not change is called a constant. So this is a simple idea behind every formula in physics. So when you look into nature and want to study the phenomenon in nature, you have to identify the variables and the constants. Variable is that physical quantity that changes, while constant is that physical quantity that does not change. That's why it's called a constant. It's fixed. So today, before I will take your mind to deriving speed formula, I'll also take you to at least two types of variation. We have direct variation and indirect variation. We have other types like joint and partial. So as we go on, you understand every type of variation and what it implies. So today, I'll just be concerned with two. Direct variation says, when we say things vary, we are concerned with the variables and not the constants. When something does not change, it's of little use in the word of variation. When we say variation, we mean things changing. So if something is not changing, there is no point putting emphasis on it, because no matter the emphasis, it won't change. So it's fixed. You don't have issue with it. But you have issue with knowing how things vary. And that's why we have direct variation. In direct variation, in direct variation, when one variable goes up, the other joins. One goes up, the other one goes up too. One comes and the other one also goes down. So they go in the same pattern. That is direct. A good example is age and maturity. It's believed that as you are growing, that you should be getting mature. When you were small, you were premature. That's why most of us, when we were small, would defecate, put sand inside it and eat it, or even lick. That's a sign of immaturity in us, because we were tender. 3 months, 4 months, 5 months, they can do undo. That's why the mom needs to be close to them, because they are not mature. So the smaller the age, the less the maturity in a child. But when you get to 10 years and do the same acts of eating your own physics, you take it hard from your mom. Because as you grow, your maturity should also be doing what? Improving. This is direct variation. Another good example is happiness and money. The more money you make, the happier you become. The less money, the unhappy you become. So money and happiness are in direct variation. They are variables. Money changes, happiness changes. Yeah, you believe with me that happiness has levels. 1 million naira, 1 billion naira will not give you the same happiness. So money and happiness, direct variation. Age, maturity, direct variation. Age, class level, direct variation, provided you don't repeat class. Then indirect, yeah, one variable goes up, the other comes down. When the one that is down goes up, the one that was up comes down. They can never go in the same pattern. Indirect or inverse proportion or variation. They go in opposite levels. Yeah. There are so many variables that behave alike. And today, one of the best examples in indirect variation is our topic of concern, speed. Speed. Okay, then let's identify all physical quantities involved in the concept of speed. If you must do the concept of speed, you must know these physical quantities. Distance and time. Distance and time. Let's go further. There is no point making definition now. That will be too early. let's demystify the nature of the topic. Then we can now come up with definition. Okay, let's say we want to engage two athletes on 100 meters race. What we judge there is the speed, but you can never get the speed per se if you don't get the distance and the time involved. So for us to know the speed of a person, the speed of a body or an object, we must note distance and time. These physical quantities will help us to get our speed. First is distance, symbolized with the letter X. Then second is time, symbolized with the letter T. So how do we now get speed from these physical quantities? Okay, this is what we do. Recall, we said 100 meters race. 100 meters is defined. 100 meters. The 100 meters is fixed. Automatically, that becomes our constant. 100 meters race. All athletes must cover the same distance. All athletes must cover constant distance. 100 meters. So automatically, we know the constants in this emphasis. Distance is the constant. Then the question becomes, what then varies with speed? And that will be time. Then recall, this speed is a good example of indirect or inverse proportion. Let's see. Speed symbolized with V. The symbol for speed is V. Is inversely proportional to time. We now want to go mathematical. Like I said earlier, in physics, we derive formulas. They don't fall from heaven. Formulas are derived. So we want to build up logic now. We're saying that speed is inversely proportional to time. What does that mean? That when speed goes up in a natural world, when a body is moving, the faster it is going, the shorter the time. A higher speed will mean little time. If you are fast, that means you cover gap in little time. That's what we call speed. So when your speed increases, your time diminishes. That logic is what we're putting on the board mathematically. That speed is inversely proportional to time. The higher the speed, the shorter the time. The higher the speed, the shorter the time. However, the lower the speed, the higher the time. If that logic is still difficult to understand, let me give you a clearer example. Okay, let's presume that a mother has two sons in the home and the mother is cooking soup. Then the mother notices that there is no salt available in the kitchen. Then the mother wants either of the sons to go and buy her salt. Then she has to consider a very important factor. And that factor is speed and time, these two variables. The mother already knows where they will buy the salt from. So it's constant. The gap from their home to the shop where they will buy salt is constant. So the mother considers two variables, speed and time. So the mother wants someone that will go and come back in the smallest time available because the pot of soup is already on fire. Yeah, it's already on the heat source. So the mother considers two variables, speed and time. The mother asks herself, who can do this errand within the shortest time available? So the mother is considering the son with the greatest speed. The mother considers the son with the greatest because a greater speed will mean a shorter time. So if you're that sluggish son, the mother will never prioritize you in this consideration. So the fastest son will do the errand. Yeah. So these are little considerations we do without knowing. We know science. Science is innate in us. So the mother calls up the son that she thinks is agile and fast. What is she trying to beat? Time. That's a simple idea on the board. The higher the speed, the shorter the time. The slower the speed, the longer the time. So that's what I have on the board mathematically. Then this is not yet an equation. It's not yet an equation. It's still a word problem. So how do you make it equation? This variation sign, the variation sign will change it to equal to and introduce a constant. So I'll have V, then change the variation sign equal to, then introduce a constant, K. K times 1 is K, all over what? C. This is now a mathematical equation where V stands for speed, T for time, K for constants. Then do not forget, in this scenario, we know our constant, and that's distance. Therefore, I can say V is equal to x over t, where x stands for distance. Recall, the athletes, they want to cover the same gap, 100 meters. So the athlete that has the highest speed will have the shortest time. So why is light considered the fastest thing in the universe? Why is light considered the fastest thing in the universe? Because light has the highest speed. Because light covers a gap of 300 million just in 1 second. Light covers the biggest gap of 300 million in 1 second. No other objects can do that for now. We've not discovered any object that in 1 second it will cover gap or distance of 300 million. Imagine you have 300 million gap and light moves and covers it in 1 second. So it is the fastest at the moment because only light can do this in 1 second. Yeah. So the idea of speed, the idea of being fast is the idea of the shortest time available. The idea of the shortest time available. Okay, so let's continue with the mathematical approach to this formula. So let's say we have 2 athletes. The distance is fixed. 100 meters is the distance. We have first athlete. We have second athlete. Okay, when we get our time device to measure the time it takes them to cover the gap of 100 meters, we notice that the first athlete covers in 5 seconds. Second, 10 seconds. So we have 2 athletes on the track. On your marks, get set, boom, the gunshot. The first athlete covers the gap of 100 meters in 5 seconds. The second person covers the gap of 100 meters in 10 seconds. So the question becomes, who is the faster athlete? You already know the winner. The person with the shortest time is the winner. But we need to prove it mathematically. Then what do? We go back to our formula. For the first athlete, what's the distance? 100 meters. For the first athlete, what's the time taken? 5 seconds. Let's now get the speed. You ask yourself, 10 divided by 5 is 2. Then drop the 0. 20. 20. But 20 is not an appropriate measurement. 20 can mean anything. So we need to put the units of speed. Then the unit is also derived. It's not to be crowned. Deduce it yourself. Notice. Ask yourself, what is the unit of distance? Meter. Meter. Over. Put it there. Over. But in the unit, we call it per. Per. P-E-R. What's the unit of time? Seconds. So the first athlete has speed of 20 meters per second. 20 meters per second. Or you can put your meter per second as, it can also be put as meter seconds raised to power minus 1. It's allowed. Meter per second or meter second raised to power minus 1. Mathematically, x raised to power minus 1 simply means 1 over x. Mathematically, 1 over x is the same thing as x raised to power minus 1. Then every whole number has a denominator of 1. Then let's prove that these 2 things are the same. Or these 2 things are the same. Okay. M times 1, m, over 1 times x, x, meter per second, or mx raised to power minus 1. That's the unit of speed. Then someone may ask, why is speed symbolized with V? See, in physics, we're not actually concerned with the symbol. Provided you know what you're doing, you can attribute any letter as a symbol. But most times, why we maintain a particular symbol because of uniformity. So that when you go to textbooks, you not get confused. So the most used symbol for speed is V. That V is velocity. Speed and velocity are almost the same. Almost. The only thing that differs them is direction. Speed is distance over time. Then velocity is speed that has direction. I know it may seem confused, but it's very simple. Let me give you an example. Anytime you leave home, you leave your home, and you go to, forgive me, and you go to a friend's home. You leave your home to a friend's home. Okay, paying attention. And you tell your mom, Mom, please, I want to go visit a friend. And you leave. You've covered distance. You've covered distance. You are moving from the point of your home to the point of your friend's home. And that must happen in time interval. So if peradventure by midnight you are not back, then the home is not settled. So there will be a kind of unrest in the home. They will begin to wonder, why are you not back? And for them to find you, something is missing because there is something you didn't provide. Direction. You did not provide direction. So it becomes very difficult for them to find you. Why? Because you may have many friends and you did not specify the friend. So nobody can find you on the spot. Or nobody can find you with ease. So you suffer your home or your parents before they will find you because you just walked with speed. But when you say, Mom, I'm going to Emeko KK's house, this is what we call direction. We now know where you've gone to or where you are going to. You are now leaving the point of your home to the point of Emeko KK's home. So you can be easily found because you know the direction. So this is a simple idea that differentiates speed and velocity. It's easier to walk with velocity because direction is specified. So velocity is speed with direction. Emeko KK's house is specified. We know where to find you, but a friend's house is not specified. A friend can mean any friend at all, any person at all. So nobody can find you with ease. That's speed, distance, covered in time. But when we talk of velocity, we talk of displacement covered in time because displacement is also specified in direction, whereas distance is not specified. So speed is distance over time, while velocity is displacement over time. But fortunately, they share the same formula and they share the same units. The only difference is that distance has no direction, displacement has direction, speed has no direction, but velocity has direction, but they have the same units. So it's only direction that differs, and they maintain the same logic. The higher the speed, the shorter the time. The higher the velocity, the shorter the time. So here, I believe that you now see that speed is a good example of inverse proportion. Inverse proportion. And it's a formula never to forget because you understand the idea. So when a driver is speeding up, the driver is trying to do what? To buy time. To buy time. So the higher the speed, the shorter the time. But recall, in life, there should be a kind of templance, balance. There are other factors that may come up with very high speed. But anytime you want to beat time, you want to accumulate a shorter time, you should be thinking of greater speed. But don't forget the idea of balance because there are other factors on the way. So speed is a very simple idea. And the form for finding speed is rooted in the logic that says that the higher the speed, the shorter the time. And the constant there is what? Distance. In summary, recall, we have direct variation where two variables go in the same pattern. Indirect, where they go in opposite levels. One goes up, the other one comes down, or opposite pattern. Then a good example of indirect variation is speed. That reminds me, we have three kinds of speed. Three kinds of speed or types of speed. We have average speed. That's the one that we just showed on the board. Average speed. Average. Yeah. Where you get total distance and the total time, then divide the total distance with the total time. That's average speed. So let's make a solving on average speed. So to get the average speed of the first athlete, what's the distance? 100 meters. What's the time taken? 5 seconds. So I have 20 meters per second. This is average speed, total distance and total time. Average speed of the second athlete. First, second. What's the distance? The same, 100 meters. What's the time for the second athlete? 10 seconds. The speed becomes 0 cancel 0. 10 meters per second. Okay. Please do notice something. The first outlet, the speed of the first outlet is 20 meters per second, and the time taken was 5 seconds. Second outlet, the speed is 10 meters per second, and the time taken 10 seconds. Okay, please do notice something here. If your answer goes against the logic that gave rise to your formula, it's wrong. That's one beautiful thing about physics. You can imagine your answers. Recall, higher speed implies a shorter time. Slower speed implies a longer time. Okay, let's see it from the solution. Here we have higher speed. See high speed. Then see short time. A shorter time. Here see lower speed. Then see longer time. In accordance to the logic that gave rise to our formula. The higher the speed, the shorter the time. The longer the time, the slower the speed. That's a good example of average speed. Then we have another thing called uniform speed. In uniform speed, when you are moving, and you notice that in every distance interval, you have the same time interval. The speed is said to be uniform. For instance, if you're a driver, in every 20 meters you drive, you cover 5 seconds. Every 20 meters, 5 seconds. Every 20 meters, 5 seconds. That is uniform speed. There is no change. In every 10 meters, 1 second, 10 meters, 1 second. In every 200 meters, 10 seconds, 200 meters, 10 seconds, 200 meters, 10 seconds. It's called uniform speed. Every point, every interval that you solve, you get the same speed. It's uniform or constant speed. A good example is the Mother Earth herself. The Earth is moving with uniform speed. That's why we don't notice the motion. Another good example is the airplane, the aeroplane at its peak of flights. It begins to move at uniform speed, which permits the passengers to move freely without noticing the motion of the plane. Even the ship. That's why passengers in the ship don't know the ship is moving, because it moves at uniform speed. When it has maintained uniform speed, continues with that. So you can now move freely without stagger. Uniform speed. All planets, satellites, stars, they go at uniform speed. They are moving by at uniform speed. Uniform speed is almost the same as being at rest, if not the same, because we think we're at rest on Earth's surface, but we're not at rest. We're moving at a very high speed of 460 meters per second. That's the speed of the Mother Earth. The Earth in 1 second covers distance of 460 meters. That's our speed, but we don't know because it happens uniformly. Then we think we're at rest. So uniform speed is the same as being at rest. Uniform speed. So the last type of speed is instantaneous speed. Instantaneous. Just like the name sounds, instant means at the very moment in time. This is what you see in a car. There is a part in a car, a component of a car called speedometer that measures the speed of the car. The speedometer gives you instantaneous speed, the speed you are driving at the moment. If you are driving at 170 km per hour, it tells you this is your speed at the instant. If you go to a higher speed, it tells you so that when you want to kill yourself, you know. So it gives you the exact speed at the time. That's what we call instantaneous speed. The speed we are moving at the very instant in time. Instantaneous speed. Average speed is gotten by dividing total distance with the total time, like the athletes. Uniform speed is when at every interval of distance and time you get the same speed. Equal distances covered in equal time intervals. Uniform speed. Instantaneous speed is the speed at the very moment in time. Thank you so much. I believe with the little I've said, you now have a clearer view of what we mean by speed or the concept of speed. Stay tuned. As we go on this course, you have so many physics findings to learn, and I bet you this is a path that will make you a better scholar in the field of physics. Thank you so much.